Stanford and I, we don't agree on much, but what we do agree on is by the end of the day, we want you developing and running your own RAS. It's always the goal of day one, is get you into the software as much as possible. And so we feel like we need to go through all the steps. And then if you have questions about them, hopefully you'll figure them out when you're doing the workshop later on. So we're gonna talk about how to develop a RAS model in the new beast we call 2025. So to start a new project, you guys have all seen this today. When you open up RAS, this is a screen you are greeted with. You also can access this screen from the file menu. It's file projects, not open projects. Also Control P. So we're gonna go here. As you guys will see tomorrow morning, I hope, when you open up RAS, this is where our little banner where you can update. Right now, this is the main window and where you would go to create a new project. But the one thing I want to touch on, we haven't touched on yet, is that it's important to know how to set the default project for where things are going to go. So when you downloaded that model, how many of you guys said, where did that go? Yeah, most everybody. I know it happens to me frequently until I got comfortable with it. We have a default project folder. The way you get to that is through the settings button on that main window. And so right now, the workflow is every project you download or create is going in this folder. We will address maybe not doing it that way in the future or having additional ways to do things, because I know for most of you, that's not how you do your workflow, right? You organize your RAS models by study area. And in that, so you have a folder that has like your hydrology and your hydraulics and your blah, 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 blah. But right now, this is where it is. So I just have one default folder. You're gonna start your new project. And when you do your new project, then the things you're gonna enter are, you can give it a project name. That project name is going to create a folder on disk. So it's not only the name of your project, it is also gonna live in that folder by that name. Make sure that you give it a description. There's nothing worse than receiving a project from somebody and not knowing who created it, when they created it, or why they created it. How many of you guys have done river hydraulic models and you started with a model that was used for CWMS? Okay, would it have maybe been faster to start from scratch? Probably, right? They're looking for different answers than probably what you were looking for. CWMS has to run fast. All you really care about is water surface elevations. Maybe hydrograph timing, right? But velocities aren't important. Little other nuances that we can go into. But knowing the purpose of the model is important. So right now, we only have a description thing. I'm hoping in the future, I think it's in our work plan to have a template to try and template some of our data to make documentation better. But for right now, try and use the description boxes to help that next person that comes along. After you provide your description, you're gonna set your projection. You guys have seen it twice today already. Drag and drop a PRJ file on there, that's the best way. You can search for projection by name. I'm probably the only person in here who will say don't use it that way. Stanford loves it. I don't, because I don't trust EPSG codes. So if you've been around GIS data enough, you know that units are super important and those are buried in the EPSG codes and sometimes they're not right. So I always like to read the projection file myself and make sure that I get my vertical units right. Until recently, there was a lot of EPSG codes that were not in customary units, they were only in metric. So spatialreference.org is your friend, it's easy. They have everything up there. RAS Mapper, we have a quick link to it. You guys should have already been there in the past, but we're gonna make this greater every day. Just right now, be careful, just searching blindly. We have you specify projection at the get-go because everything we're doing in RAS is gonna be geospatial. You add a pump station, you add a weir, everything is gonna have geospatial coordinates associated with it. We want you to get used to starting with that projection information up front. So you enter in your information, including a description of who you are and when you create it, and hit create, and that's going to create on disk a folder in that default project location. So in this case, I don't know, this was like my example step by step. So there's a folder called example step by step, and then I'm also gonna have a RAS project. My favorite thing about RAS is that the RAS extension is actually RAS now. So no longer will anybody be confused between their projection file and their RAS project. We were here first, just remind the ESRI people that. PRJ has lived a lot longer than the PRJ file, I think. When RAS comes in, it's going to default to some random location. Random in that if you're zoomed out far enough, you don't know exactly where you are. What the boys are doing, just taking the center of whatever projection you've specified, and that gets centered on the map. Okay, so yeah, I got California Zone 3 defined here. It's centered on my map. What you're gonna find that you need to do is either zoom in to, if you know where you're going. I always drag and drop a shapefile on there. So typically, if we're doing a modeling effort, we have some supporting GIS data, and I use that to locate where I wanna do my work. Okay, so we drag and drop, and then we can zoom to our layer, and then we can get started. First step, we're gonna create terrain. Eric went into detail of all the cool things we can do with terrain. The cool thing about 25 is that if you already have a terrain layer, you don't have to recreate it. You can just drag and drop it, and RAS will say, hey, this looks like a terrain file, I'll add it to your terrains. Alex and Zach have spent a lot of time making sure that you can not only manage your data through the RAS interface, which is gonna get better and better the more time we have, but you can manage it on disk in something like File Explorer, where Microsoft has tons of money, and they already have really great tools, so why not take advantage of them? So that integration with the file system, it's a game changer until we have UMLs and some other things that are going to really help you manage your RAS project. Let's talk about land use, land cover. We saw a little bit of a mention when Alex was doing a demo, but let's talk about the two different workflows we have available to us to create our surface roughness layer. There's two ways. Right now, the Manning's N value layer, we store it under a group called surface layers. And it's just like every other group. If you want to create something new in there, you click the plus sign to the right of the title. When you do that, you're going to get two options. One is to add a Manning's layer, and the other is to add a classification layer. Okay, so the easy way is just to add a Manning's layer. So you just click the left button there, and it'll create a layer for you. And you can come in and just choose a constant value. It'll look geospatial. A surface actually gets created, and you'll see a big yellow blob because the default value is 0.06, and the default color for 0.06 is yellow. So turn that on. If you see a big yellow blob, that means you have something, and those are your values. The other way to do that is to create a classification layer first. So if you click on the option on the right to add a classification layer, you'll get a different interface. And as Alex noted previously, we've gone to the trouble to take from the MRLC database and download the land cover data from it. And we have it sitting on HT servers, so you can import it directly into RAS. So it's been pre-processed, so it's fast. Once you create your classification layer, you can import the NLCD directly. So when that comes in, that's great, it's quick, it's easy, and it gives you a start. As we all know, we're not gonna use this for our final roughness surface, but it gives us a good start to get our model up and running, right? So we get that into our map. So here we have our land cover data set. At this point, we can either keep it as is, or most likely we're gonna want to augment that data with data that we either download from another source, we get from the state we're working in, another GIS, or we create it by hand. And so the support that we have built into this right now is that just like the terrain data set, we can stack layers. And so what we have is we have a classification polygons layer that's stacked on top of the data we downloaded. And those classification polygons are your ability to essentially override the data that's in the data set, okay? So that is a vector data set that you can either import a shapefile into or digitize by hand. So if we make that classification polygon layer active, we then have the option to take the edit tool and create polygons. Okay, pretty straightforward, very similar to RAS Mapper from the outside. Behind the scenes, it's a little bit different. We'll have the ability to do our vector overrides, digitize a polygon. You guys just learned how to do editing. Editing tools work the same for shapefiles. Digitize your polygon, provide a name. Once you've provided all the classification polygons you're interested in, you can then convert this layer directly to an N value layer. And so when you do that, it will go through and create a data table for you with the Manning's N value column. We've also added a little button so that we can set these default values for the NLCD data. It's this little set NLCD data button. It'll set them to what is the average of the published values from Chow's Handbook of Hydrology. So it is just a start. The only ones that are kind of made up, they're from practical experience and they're actually from 1D modeling. So they might be a little bit high. I think I chose up the lower end of it, but this is what we've historically used for 1D modeling for the developed category. But everything else is from published data. Again, from 1D modeling. For that end value layer that gets automatically created, if you want to switch modes, this is where we would switch our mode. So if you want to go back to a single value or you started with a single value, you can do single value and then swap it to classification. You've created a project, you've created a terrain layer, you've created your end values. The next thing you're gonna do is create a geometry. So to create a geometry, just go to the geometries group, click the plus sign, provide a name, hit create. When you do that, you'll check the components tab and make sure that it properly associated your terrain and your end value layer. We just had a nice discussion about the conceptual mesh. So in creating the geometry, we're going to create our conceptual mesh. We're then going to create our regular mesh by editing our regions with parameters. We're gonna go into this in detail tomorrow. You'll create your mesh. If you wanna know how many cells are in there, you can click on the mesh button and under components, it'll tell you how big your mesh is. So you can get an idea for, I find this very helpful to know whether I can go get coffee and come back or whether I can just keep working. And then we're gonna talk about boundary conditions tomorrow, but today's your little introduction to boundary conditions. Once you have your mesh set up, again, it's like everything else. You're going to click the little plus button next to the boundary conditions layer, and it will bring up an editor where you provide a name. And then the new thing that you're gonna learn about in RAS 25 is we have the ability to set the time window for your boundary conditions at that point. We don't wait all the way until we get to the plan. So you can enter a time window for your boundary condition data and hit create. And then we go to our boundary condition lines and we start adding those just like we did in RAS Mapper. Okay, so here we have a simple model. We have a boundary condition at the upstream end as our inflow and then a downstream normal depth condition for the downstream boundary. So you enter your hydraulic data. Then just like RAS, we're gonna create a plan where we marry our geometry and our boundary conditions with some computational settings. When it comes to a time window, if you select your boundary condition as your time window, it'll self-populate for you. There's also an option you'll learn about tomorrow where you can override that and just pick a smaller time window. So you set up our plan after the time window's been entered. And with that plan, we want to set our computation options. Today, you won't have to set many of the computation options. You're just going to pick what equation set and a time step and then hit go. And you'll see how the plan editor is organized where we have just the necessary information in front of you. And there's a whole bunch of advanced stuff, which maybe we'll get into tomorrow at the end of the day or maybe never, depending on how much fun you're having. Set the equation set, choose the time step and hit compute. And then you'll see a little running man. And he will be running and running and running and hopefully he won't trip. As it's running, you'll see a log file. So a little log file comes up here. We'll talk about the log file again tomorrow. We'll talk about some of the diagnostic output that we already have. And you'll be able to click on your results, be able to animate it, much like you can do in RAS Mapper, and then plot some various things. And again, I don't want to give too much away today because we have a whole presentation on all the intricacies of what you could do tomorrow. It works a lot like RAS Mapper does, just much cleaner. And the one thing we can do is we can query time series. So go ahead and play with the time series query and then animate the results and see how the two interact. Okay, Jet's put a lot of time in the results plot. They look really cool. They look much better than when I took the screenshot 6 days ago. When you're playing with the results, pay attention to what type of result you're looking at. That's important in interpreting the data. That's how easy it is to get a RAS model going. Now that you know how to create a conceptual mesh and create the computational mesh, the other stuff in RAS is all very similar. Create your geometry, create your boundary conditions, create a plan, and then hit go.